Hello everyone, welcome back to the channel. In today's video, we're going to be covering control structures in Arduino programs. First, in order to do this, we need to cover what are control structures. Control structures use conditions to change the order of operations in a program. So to write this out, use conditions to change order of operations in a program. To go over what this might look like in a program, so say you have the start of a program up here, right? This is the start. It goes down. The program continues as expected, but suddenly it reaches a condition, right? We're going to abbreviate it as COND, a condition. And now the condition can either have two sides. One is that the condition is false, and the second one is that the condition is true. Now, if the condition is true, there will be a statement, and if the condition is false, there's going to be a separate statement. However, what they both have in common is that they're both going to reach a common end. So we can write this out, and down here we can write end. So you can see how this works in practice. So right here is the control structure. Control structure. What it does, it uses a condition to alter the order of operations in the program. So we can see how it goes. It can either go down the true pathway or down the false pathway. And these will both have their separate statements, which are identified right here. And that's essentially how the order of operations is changed in a program. In this video though, particularly, we're going to be covering while loops, do while loops, for loops, if statements, and else statements. So without further ado, let's get started by talking about while loops. So the function inside a while loop will loop continuously until the expression inside parentheses becomes false. And now the expression inside parentheses, if I would like to remind you, equals the condition in a while loop. Right, so earlier we talked about how there's a condition that can change the order of operations. That's what the expression inside the parentheses refers to. So for a formal definition, the function will loop continuously until condition false. Right, so the moment the condition becomes false, the while loop will stop running and the code will move on to the next aspect. For example, if you had a constant, you would not really use it in a while loop because it would never change value. It's a constant. This is why when using while loops, you often want to work with the state of a sensor or the value of a variable that might be changing throughout the program. But to do that first, we need to go over the syntax. So the syntax for a while loop is as follows. While condition inside parentheses, fancy bracket here, and then your function will fall inside here. So the statements of function. And then to close it all out, on the line following the very last line of the function, you would use the closing bracket to match this one up here. So you might have noticed this image here on the right. Now, this is an example of a while loop in practice. In this instance, var is a variable initially set to the value of 0. However, as you can see, as the loop continues, the value of var increments by 1, as you can see with this compound operator ++. Now, if you don't know about compound operators, a video about those will be coming out soon, but just for now, all you need to know is that var ++ means that the value of var is going up by 1 each time this loop runs. So as you can see here, we have while, like we do down here, and then we have our condition inside the brackets. Now the condition says while var is less than 200, then the function would run inside. Now here it says the function will run 200 times because var initially is set to 0 and it's adding 1 each time, so it really does make sense that this function would run 200 times. So thus, when var is no longer less than 200, this condition inside the braces will no longer be true, and the program will move on to the next aspect. Alright, now let's go on to do-while loops. So do-while loops are effectively the same as while loops, with the exception that the condition is tested at the end of the loop's first completion. So let's write this out. Effectively same as while loops, but the difference comes at the end. So the condition tested at the end of the loop's first completion. Said another way, the do syntax instructs the loop to run at least one time, and then once the first loop's first cycle has been completed, the program evaluates the truth of the condition in the while statement that follows the closing bracket of the loop. So, as you can see here on the right, here's an example of a do-while loop in practice. In this example, the integer x is initially defined as 0, but in the loop, x is specified to be a return value from reading the sensors. Therefore, when x is no longer less than 100, no more delays and read sensors operations will occur. So we can see here that, right, the function runs at least one time because it's telling it to do something, but then once that has already been completed, the while loop comes. Once the while loop comes, if this condition is true, this loop will repeat, whereas if the condition is false, then the program will move on to the next aspect of code. Alright, now we're getting on to the third and final loop function that we're going to cover today, and that's the for loop. So the for loop repeats a block of code in enclosed braces, and increment counter is usually used to increment and terminate the loop. And for loops are especially useful for any repetitive operation, especially when you want to specify the number of times the operation is executed. So let's write this down. Repeats, just like all other loop, it repeats a block of code, enclosed in braces. Different to a while loop, however, an increment counter is usually used to increment and terminate the loop when the increment runs out. So increment counter. And if you don't understand what this means in the moment, don't get discouraged. We're going to cover it with an example that you see on the right. So an increment counter used to increment, usually it's the value of a variable being used inside the function of variable. However, when the value of a variable reaches a certain point, that's when the for loop will stop. So for this reason, they're useful for any repetitive operation, especially when you need to specify the number of times the operation will be run. So to use for loops, we need to first cover the syntax. A for loop is basically executed like this. You start with for, and then the condition falls inside the parentheses as usual, but what's special about for loops is the following. First, you start with initialization of a variable, then there's a semicolon followed by a condition, and then after the condition there's the increment counter, which we explained above, which we'll just abbreviate as increment, and then the closing bracket, and then the opening curly brace, the statements, the usual functions that fall inside, and then it closes with the other curly brace. So here's an image of a for loop in one of my programs, and what's important to note is that I++ is a compound operator that increments the value of the variable, in this case I, by 1 each time the loop runs. So usually the increment is specified with compound operator, which we'll also get into in another video, but all you need to know is that this is incrementing the value of variable I plus 1 each time the loop runs. So here you can see all the components we outlined here below, right? We have an if statement, which is not that important for this, but we have a for, and we declare the integer I equals 0. So that's the initialization of the variable. We don't declare that variable outside of the for loop, we declare it right in the middle of the condition. Then we have our condition right here, which is while I is less than this variable I specify here, which you don't know what it means yet, but that's not entirely important. But while I is less than that variable, the loop will keep running. And then afterwards, we obviously increment the value of I by 1 each time. So once I reaches a certain value, then the for loop will stop running and the program will move on to the next thing. This video is starting to run a little bit long, so in the next video I'm going to focus on if statements, else statements, and else if statements so that this video doesn't eat up too much of your time. So with that said, thank you for watching. If you have any questions, feel free to leave them in the comments below and I'll answer them happily.